My work with the Neukom Institute was a continuation of my senior thesis, which was titled Modeling Multiple Stressor Effects on Daphnia pulex. Current regulations for aquatic contaminants are based on individual contaminant data. So the EPA will take a single contaminant like a heavy metal or a detergent or some other toxin and look at the effect of a range of concentrations of that contaminant upon an aquatic organism. In reality, you almost never find an aquatic system that only has one contaminant present. You almost always have a mixture of contaminants. And the relationship between the effect of contaminants in combinations and the effect of contaminants individually is not straightforward. It's not what you'd imagine it would be. A number of different models have been suggested for taking single stressor data and using it to predict the effect of mixtures of contaminants. So my work was focused on testing a number of those different models and seeing how well they could predict the effect of two metal stressors in combination upon Daphnia pulex. They're a very important species in most freshwater ecosystems, and they also are one of the most sensitive to toxins, so they're often one of the first groups of organisms affected when a system is contaminated. The first step in my project was to look at the effects of nickel and copper individually upon Daphnia pulex over a range of concentrations. Then, in conjunction with a professor from the mathematics department, Eugene Demidenko, I wrote a program in R that took that individual stressor data, ran it through each of the models that I was evaluating, and outputted a response surface, which is a three-dimensional figure that shows for all possible combinations of concentrations of nickel and copper, the effect that you would expect to get based on each of these different models. And then finally, the last step in my project was to actually experimentally evaluate the effect of combinations of nickel and copper upon Daphnia and compare those experimental results with the predicted results to see how well my experiments conform to one model or another. If a model could be developed that reliably predicted the effect of multiple stressors from single stressor data, then EPA regulations could shift towards being based on the total concentrations of all of these different contaminants in systems rather than individual toxin concentrations. An understanding of toxicity that's based on multiple stressors is more representative of what's actually happening in these systems. So in theory, those kinds of regulations would do a better job of protecting those ecosystems. I'm really passionate about the application of biological principles to solving real-world problems. So I really want to take my education in engineering and my education in biology and use them to take an approach to problems that people who are strictly one discipline or the other might not see.